Hey guys, welcome back to another episode of Math Lessons with brrly. So I was watching the other episode that I just filmed like 10 minutes ago, and there was a lot of muffling. Um I don't know why that is. I wasn't even moving my iPad around that much, I think. Actually no, I was touching it quite a lot. That also happens when I film videos on my MacBook. Like well, I've never told anyone this except for like probably yeah, but I've never told anyone this. But like I used to film videos of myself coding, and then I would like post them on YouTube, but like unlisted, so I could like watch myself code, cause it's like motivation. I don't know, but that's not really a big secret. I didn't want you guys to think it was a big secret, but it's just yeah. But now they're public on the channel that they're public on my channel right now. And yeah, so if you guys want to watch those you can, but just know they're kind of boring. Like I don't even talk in them. I just code. And like the typing's really aggressive and it's kind of I don't know, typing ASMR I guess, but anyway. Um Rationalizing denominators is our math topic for the next probably 20 minutes. So rationalizing denominators is just making the denominator rational. So like an irrational denominator would be like this. Because you see the radical is in... Okay, that eraser's too big. There's a radical and that's not very rational, So to do that, you would have to multiply this fraction by a conjugate. So a conjugate is pretty much just like, right? Wait, do you? Give me a moment. Conjugate? Is that what it... Give me a moment, guys. I'm going to search it up on Google on my laptop. Conjugate. Grammatical. I don't care. Oh, I think you just multiply it by 2. Like one of... Oh, yeah, okay. So, you just multiply by square root of 2. You don't multiply by the conjugate. The conjugate is something that I will teach you guys later on in this video, even though you guys probably already know it, but if you're in algebra right now and you're watching my video, you probably don't know what it is because you learned that like later on in the year. Like right now, I think you guys are on... Actually, I don't even remember, but you're not going to be on this for a while unless your curriculum is different, but I almost burped. Give me a moment. Okay. So what you just gotta do is multiply this. So like, when you're like, when you have a fraction like this and you want to get the whole number only, you would have to multiply that by a 3. So 3 over... Wait. What? Okay, I was talking about a completely different thing that's not even related, but, if you just want to get rid of it... Wait. What? Times 1... Oh, wait, yeah. So if you have like 2 over 3 in an expression, no, 2x, and you want to get rid of the fraction, you would have to multiply by 3 to cancel those out, because 3 over 1 times 2 over 3 is equal to 6 over 3, which is just equal to 2. So that means you just canceled it out, and then that means 2x is equal to 6x, which is not true. So, but that was just an example of how you would cancel out a fraction in an equation. But if you have an expression like 2 over, and you want to like get rid of the fraction, you would have to multiply it by 3 over 2, right? No. you'd have to multiply it by a number that is equal to 1. So like, for example, 3 over 3 is equal to 1. 3 over 3 is equal to 1. 4 over 4 is equal to 1. All those numbers are equal to 1, right? Because in an expression, the expression still has to equal itself, or else the expressions, like, for example, if you did 2 over 3x times 2 or like 3, this is an expression. You would get 2x, but 2 over 3x is not equal to 2x, so you did not simplify the expression correctly. Like, if you're solving for an equation, then you could multiply by 3, but if you're simplifying an expression, you can't. I think that was a useless rant that I just went on, and you guys didn't need to know that, but you know, who cares? So now we have this 6 over 9x, and then 2 over 3x is equal to 9 over 6x, so you just simplified it correctly, even though it's still a fraction. Anyway, but, another simple rule with square roots, if you're multiplying, so like 4 can be derived, or is that, dude, am I using derived right? Derived, obtain something. What does it mean to derive? So 4 can be derived from, 4 can be derived from, or the square root of 4 can be derived from the square root of 2 times the square root of 2. So that means, and the square root of 16 can be derived from the square root of 4 times the square root of 4. So what do you think that means, guys? It means that any number times the square root of itself, the square root of any number times the square root of itself. What? So the square root of any number times the square root of that same number is equal to that number. You know? Yeah. Okay, cool. So that means when you multiply that stuff together, you get rid of the rational thingy, which is why we're doing that right now, and why we're doing the fraction thing. Anyway, so that is 2 times the square root of 2 over 2 times the square root of 2 times the root of 2, so that would be 2 times square root of 2 times square root of 2, that is equal to 2, because you just get rid of the little thingy. Then 2 times 2 is equal to 4. Did I do that right? I think I did. Okay. And then you can just simplify that, which is 1 over 2 times square root of 2. And you just simplified a rational thingy. That took a while to explain, cause wait, I'm gonna move this over here. Sorry for taking so long to explain, but you know. Now let's do, that's a weird one. Okay, let's do that one then. 1 over 3 times 3, 2, it's an ugly 3. 3, 3. What are we simplifying? Let me sort. Oh, oops. That's not what we're simplifying. But it was a step of it. Okay, 12. So now we're gonna try to simplify this. Yippee-ki-yay, guys. So in the last video, I did this thing where I derived the square root of 144 from 2, 4 times square root of 3 squared, because it's the square root of 12 times the square root of 12, since the square root of 144 is 12. And then you can do square root of 3, square root of 4, which is 2 and 2. This is the same thing. So since you can do that thingy, now we know how to simplify this. So square root of 12 is the same thing as the square root of 6, which can also go into 3 and 2. And the other one is 2, so that means, yeah. So that means this is equal to 1 over the cube root of 2 squared, because there's 2 of these, times the cube root of 3. There we go. Okay. And now to simplify that, we have to rationalize it, because that's what we're supposed to be doing. Oops. What do you... Okay, let's just multiply it by... wait, what? Okay. Why aren't we multiplying by 3 times 4? I don't get it. Wait, let me try it out. Let me try it out the textbook way, and then I'll try it out the 4 way. The one that, yeah. So you multiply by the square root of 2, 3, to get rid of this thing. And then you get the cube root of, cube root of 2 over, what is this? Cube root of 2 times cube root of 2 squared. What would that be? I think it's just, oh, I forgot, you just multiply the things inside. So that is just equal to cube root of 2 to the 3rd. So that's just 2. Okay, so 2, and then you don't distribute it since it's being multiplied. Since this is a multiplication expression, not a addition. Oops. Wait. So there we go. Then we just have to get rid of this thingy. Let me erase this stuff. Then you do multiply it by 3 over 3, which is equal to, oh, I forgot to mention that a fraction is still rational if the numerator has a radical in it. A radical is the little thingy, by the way. But I don't know why that is. Maybe I'll search it up later, but it's probably like some complicated math that I'm not gonna understand because it's weird like that. But yeah. So since the denominator cannot have a radical thing, but yeah, okay. That's the cube root of 6, right? Right? Why is it squared? What? Rationalize 3, 2, 2 times square root of 3. Why is it squared? Sorry guys, I'm just a little tired, you know? god, that makes so much more sense. Okay, so if you have like a fraction like it's just the square root, you would just multiply by the square root to get rid of the square root, because a square root times a square root is equal to the number that's under the root. But if you have a cube, then you would have to multiply it by another cube, which is why they're multiplying by the exponent things. Oh, that makes so much more sense, guys. Oh my god, I'm so smart. Anyway, you would actually have to multiply by squared, because right here, this is only 1. So the third root of 3 times the third root of 3 does not equal 3. Whatever I wrote down here was not correct. Oopsies. Good. Hello? Hello? Okay, there we go. It would have to be this. So, that means you would have to be like this times 3 times square root of 2 squared is equal to 2. Or, because like when you have that thingy times that thingy, oops, then you have this thingy, you know? Awesome. Okay, so let's get back to the problem. Sorry for being so slow. But anyway, I don't know if that makes sense for you guys, but you can search it up. I don't know what you'd have to search up, but it makes sense to me. Wait. Yeah, okay. 3 times square root of 2 times 9 would be 18. Then 3, so these would cancel out to be 3, so it's 6. There we go. Did I solve it correctly? Yeah, I did. Okay, awesome, guys. I'm so smart. Let's do just one more problem because I'm kind of tired. And we have school tomorrow. Studious, but not too studious to the point where I miss out on the actual studious, where the studious has to be studious, you know? What is this? No. Oh, I said I was going to teach you guys about conjugates. Okay. Let's see. Okay. Number 3. We have 1 over square root of 7 plus the square root of 3. So here you would have to multiply. So a conjugate is pretty much, so let's think of A plus B. So the conjugate would be A minus B for A minus B, I'm pretty sure. I think. Wait, what is it? Conjugate math. Oh, I'm a liar, guys. Wait, no, I'm not. Wait. Yeah, okay. So if you have A plus the square root of B, then the conjugate would be A minus the square root of B. And the other way around. You know what I mean? Okay, so conjugates just help you get rid of stuff in the denominator, I guess. I remember there being something more. I don't remember though. It's like A minus B stuff. I think it's in the textbook. Give me a moment. Show that the conjugate radical, we find the conjugate of by changing the sign in front of one radical term multiplying top and bottom by the conjugate radical of an expression in the denominator will always make the denominator rational. This only works for square roots and only for two-term expressions. Oh, square roots. It doesn't work for cube roots, guys. Oops. Show that the product of A, B, and A is always rational. Ooh, it's a proof. That's not funny. Actually, no, that's important. I'm gonna research more on that later. Or actually, I should do it right now. After I solve this problem for you guys. So, what we would multiply, what do you guys think we would multiply by? What if we have a fraction? Oh yeah, okay, I was right. Square root of 7 minus square root of 3 over square root of 7 minus square root of 3. So you multiply that to get square root of 7 minus square root of 3 over square root of 7 plus square root of 3 times square root of 7 minus square root of 3. I don't know what that equals, so give me a moment. So that would equal 7 minus square root of 21 plus square root of 21 minus 3. So that gets rid of this stuff, right? Okay, yeah. So you just have 4. Cool. Awesome. I think I did that right. Let me put that in my calculator real quick. 1 over square root of 7 plus square root of 3. Yeah, I'm always right. I know. Anyway, now it's time to show you guys the proof that was in the textbook, because it'll probably help me engrave this stuff in my brain, you know? Oh wait, it's not even a problem. Who cares? Okay, so A times square root of B plus C times square root of D times A times square root of B minus C times square root of D. So imagine we have the problem that we just did. In this case, A and C are 1. So now, when you multiply this, you would get... I'm not doing the math, so I'm just going to follow the textbook. You'd get A squared B plus A times square root of B times negative C square root of D. So this right here is just A times square root of B times A times square root of B. And then these, so here, go from that. Wait, let me set this up better for you guys. Oops, not you. Go back. So you have this one and this one. So that's this one. Then you have this one and this one, which is this entire thingy. Then you have more. Let me write that down too. Plus C times square root of D times A times square root of B minus C to D. And this is negative C times square root of D. Wait, yeah, okay. So it's positive times negative C times D. Oops, that's too big. Okay, and then these are just the factors. So this one and this one. Oops. That one, and then this one and this one. I think you guys get that. Let me highlight the chapter thingies. I don't know if you guys understand that, but yeah. And then now we have a to b minus ac times square root of bd plus ac times square root of bd. So these are just, yeah, those thingies. Minus, hey, what the frick? Minus c to d. And then these would cancel out because it's a negative plus a positive of the same number. So identity property, I'm pretty sure. Then you get this. And we just got rid of the radicals, so cool. Yeah. And that's pretty much the proof thing. I think that's cool to see. So I'm actually gonna save that right here. Or like screenshot it, I guess. Give me a moment. Screenshot. Okay. That's the end of the video. If you guys have any questions, maybe ask me. I don't know if I'll be able to help you or not because, yeah. Thanks for watching, I guess. I mean, yeah, thanks for watching. Not I guess, thanks. If you made it all the way through, awesome. If you guys need me to help, logarithms. What? How do you pronounce it? Logarithms. How to pronounce logarithms? Oh my god, I'm so smart. Okay. Logarithms. That's the next part of this chapter. That's so cool. I guess I'll do that next, even though I've never tried doing logarithms. They seem fairly simple though, I hope. But, yeah. Thanks for watching, guys. I hope you enjoyed watching me solve irrational denominator stuff. And if you guys have any questions, I probably will be able to answer them or not. I don't know. Yeah. Outro song. Okay, thanks for watching, guys. How do I stop? Hello? Oh, there. Bye!